Alright, this is lesson 79, graphing quadratics with solutions. We've done this before where we graphed. Okay, so we're going to do what we've done before and kind of connect vertex form to what we've done before, so it'll be a little easier. And we're going to connect even the quadratic formula to what we've done and the discriminant. So it's all going to start coming together now, okay? All these different things. So. Here are the steps. If you're on the video, make sure you pause and write these down. Here we go. I'm going to show you how to graph a couple things. Here we go. Number one, it says graph and identify any solution. So the first thing I want to do on number one is, I'm going to hide number two because I think I need the space. The first thing I want to do is make sure it's in vertex form. It already is in vertex form, so our h is equal to 1, and our k is equal to 2. Or I'm sorry, negative 2, right? So h is 1, because that negative sign needs to be there, and then k is negative 2. So I'm going to use that to plot my, or start my x and y chart, because that's my vertex. That's where it's going to be plotted. So 1, negative 2, this is where my vertex is supposed to be right here. Okay? I know that this graph is going to open up because A is positive. So I'm going to predict that it opens like this. I don't know what it's going to exactly look like yet, but it's supposed to look something like that. So in my head, I'm going to think that, okay? So we're going to use our H and K, and we're going to put Y and negative 2, or 1 and negative 2 right here. And we're going to pick two smaller numbers than 1 and two bigger numbers than 1. And we're plugging this back in. So starting with negative 1. Plugging it into my original equation. Okay. My original equation, let's put a negative 1 in here. Negative 1 minus 1 is negative 2. Negative 2 squared is positive 4, right? 4 times 2 is 8. 8 minus 2 is 6. Okay. Next one, 0. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. 2. 2 minus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. Oh, look at that. 3. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. Do you remember doing this a couple months ago? Or, and then, did you notice how these two are copied themselves, right? It's because it's symmetrical. Now what I'm going to do is graph. So we already know how to graph. So that's not the purpose of this lesson. Well, it kind of is. I wanted to get you more practice with this because this is an important topic. Now I'm plotting the points. And I'm graphing, right? And I'm using a nice, smooth U-shaped curve. And I'm drawing arrows at the end of each graph, okay? Now, do you remember doing this part up to now, right? Here's the new part. Remember solutions? Our solutions are where the graph crosses the x-axis right here, you see? So where does the graph cross the x-axis? It crosses the x-axis at 2 points. Here, here, and right here as well. 2 points. So what is x equal to here? One of our solutions is 0. X is equal to 0. What's the other solution? X is equal to 2, right? Right? Those are our two solutions. So by graphing, I can figure out the solutions as well. That's the new part. And let me prove it to you, okay? What if I were to just work this out and figure out... Well, I'll prove it to you on the second one, okay? So this is our first set of answers. So when it's in vertex form, we know that we're going to graph it, and we're going to get two solutions at 0 and 2. All right? Does that make sense? That's how you do number 1. Any questions on number 1? No. Watch me do number 2 now. Oh, that's not what I want to do. Let me... Okay, number 2 here. Sorry, I made a mistake on my presentation. Okay, number 2. This is not in vertex form. We have standard form now, you see? Okay. So, first thing I want to do is put it into standard form, or vertex form. So I'm going to start with h, which is h is equal to negative b over 2a. Okay? So I know that b is equal to negative 8, so it's going to be negative 8 over 2 times 1. And I'm solving this. Negative 8 is positive 8 over 2, which is equal to 4. So that's what our h is, okay? Our k, we plug it back in to the whole thing. K is equal to x squared, which is 4 squared, minus 8 times 4, plus 17. Okay, 4 squared is 16. Negative 8 times 4 is negative 32, plus 17. So 16 minus 32 is negative 16. Negative 16 plus 17 is equal to 1. Okay, that means our h and k are 4, 1. So I could literally go to my graph and plot that, right? That's our vertex point. And I know it's opening up because a is positive. So now what I'm going to do is create the vertex form of this equation. So we already know how to do that. Y is equal to a, which is 1, times x minus h, which is 4, squared plus 1. Okay? We plotted our vertex. Now we're going to make an xy table. This is the harder one, by the way. Okay, xy table here, we're putting in our hk. We said this 4 and 1. Two smaller numbers and 4 are 3 and 2. Two bigger numbers are 5 and 6. Okay, putting in 2 into here. Okay, 2 minus 4 is negative 2. Negative 2 squared is 4. 4 times 1 is 4. 4 plus 1 is 5. 3. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 times 1 is 1. 1 plus 1 is 2. Okay? What do you think this number here is going to be? 2. Let's see if you're right. 5 minus 4 is 1. 1 squared is 1. 1 times 1 is 1. Plus 1 is 2. You're right. Okay? So this last number must be what? 5, right? Okay, now we're going to plot our points. So we got 2, 5, 3, 2, 5, 2, and 6, 5. Okay, and now we're going to graph, okay? Now we're going to ask ourselves, what are the solutions? When does this graph cross the x-axis? Does it cross the x-axis at all? Yes or no? No, you could see that it doesn't cross the x-axis. Since that's the case, we would say there's no real solutions, okay? Remember yesterday with the discriminant? Let's go back to yesterday discriminant. What's the discriminant in this example? How do we find the discriminant? It'd be b squared minus 4ac. Let's just prove that there's no solutions. B squared, it's going to be negative 8 squared minus 4 times a, which is 1, times 17. Okay, negative 8 squared is 64. Negative 4 times 1 is 4. 4 times 17 is going to be negative 68, right? 64 minus 68 is negative 4. What happens when our discriminant's negative? No what? No real solutions. Did you see how that worked out? How that's connected? Okay. If I were to do the discriminant on the first problem, it would show me a positive number. Okay. So that's how it's connecting. So now you could figure out solutions by graphing, okay? That's the goal today, is finding solutions by graphing. Questions on 1 or 2? Okay, so what we're going to do now, okay, number 3. Let's do this one together. If you need to write the graphing part on your iPads, please do, with the graph paper background. Here we go. So number 3. First step, we need to make sure if it's in vertex form. Is our equation in vertex form? Yes or no? Yes. Yes, it is. Good. So now we're going to figure out what h and k are. What's h equal to? No. Remember, there's supposed to be a negative sign here. Is there a negative sign there? No. So what's our h then? What? Isn't this like saying, isn't positive 4 like saying negative 4? Yeah. So what's h equal to? Negative 4. What's k equal to? Negative 1. Good. So we're going to plot that point because we know that's the vertex. Okay. And we're going to write negative 4, negative 1. What's 2 smaller numbers than negative 4? 2 smaller numbers than negative 4. Negative 5 and negative 6. 2 bigger than numbers than negative 4. Okay, good. Okay, let's start with negative 6. Let's put negative 6 in there. Okay. Negative 6 plus 4 is? What's negative 6 plus 4 at the top? Negative 2 squared is? No, negative 2 squared is? Positive 4. 4 minus 1 is? 3, right? Did you all get that? Does that make sense? Okay, next one. Negative 5. What's negative 5 plus 4? Negative 1 squared is? 1. 1 plus 1 minus 1 is? 0. Okay, good. Next one, negative 3. Negative 3 plus 4 is? Negative 3 plus 4 is? 1. 1 squared is? 1 minus 1 is?
0.
Okay, negative 2. Negative 2 plus 4 is?
2.
Negative 2 plus 4 is? Positive 2. 2 squared is? 4 minus 1 is? 3, right? And are y'all seeing that these are symmetrical? Do y'all see how like the graph repeats itself? Do y'all see that? Yeah. So that's a hint. Check your work. Don't just assume they're always symmetrical because you might have made a mistake. Then you graph them, okay? So it's negative 5, 0, negative 6, 3, negative 3, 0, and negative 2, 3. We're going to plot our points now using smooth turn. Okay. Now turn your neighbor and identify what the solutions are, right? We know how to graph already. What are the solutions? Tell them what it is. X is equal to what and x is equal to what? What are your solutions? Okay, what's one of my solutions? Raise your hand when you have a solution. Yeah. I'm sorry?
Negative 5 and negative.
Good, so x is equal to negative 5 and x is equal to negative 3. Okay? These are called 3 things. We know that they're called solutions. Okay. They're also called zeros. Okay, let me show you why they're called zeros. They're called zeros because look up here. When x is negative 5, what's y equal to? 0. When x is equal to negative 3, what's y equal to? What? 0. You see that? So why are they called zeros? It's because y is equal to 0. Do y'all see that? Yes? Do y'all understand? And the third thing it's called is a root. A root is when it crosses the x-axis. So think of this as like the x-axis is like the ground, Okay? Let's say this is the ground. When do the roots start? When they go underground, right? Do y'all see that? So this is when the roots start, at these points. Okay, I got a question for you. Here's an advanced question. Not that hard, but I know that there's two solutions. Tell me can you describe what the discriminant should be? Should it be positive, negative, or zero? If I have two solutions, what should my discriminant be? Discuss with your neighbor. Is it supposed to be positive, negative, or zero? Discuss with your neighbor. Okay, raise your hand if you want to tell me what the answer is and describe to me what it is. Positive, negative, or zero. Raise your hand. Don't be afraid. Think about yesterday. We know there's two solutions, so what should our discriminant be? It should be positive. Why is it positive? Uh-huh. Good. It's positive because it has two solutions. Did you all get that? Okay, so you have to think backwards too. This is all connected, okay? Okay, that's number 3. I'm going to jump to another one. Let's jump to number 5, okay? Number 5, if you could write this down, we'll do this once, kind of together. Before we start, what is A, B, and C? A is what? B
is 2.
B is what? -2, thank you. B is -2. Is there a C?
No.
This isn't a trick question, right? We've done this a lot of times. So what number represents C? 0. 0. When there's nothing there, what represents nothing? 0. When I have no money in my pocket, how much money do I have? 0. Do you got that? Does that make sense? Okay. So B is -2 and A is 1. Okay, good. So let's start with what is it in vertex form already? No, so we have to write that. So we start with -b over 2a. So we have -2 over 2 times 1. -2 is equal to what? +2. 2 times 1 is? Therefore, h is equal to 2 divided by 2, which is equal to 1. Good. That's our h. Okay, then we plug it back in to find our k. You just plug it back into the original equation, which is x squared, or 1 squared, minus 2 times 1. 1 squared is equal to? -2 times 1 is equal to? Therefore, 1 minus 2 is equal to? -1. Okay, so that's our k. So now we're going to write our vertex form. Y is equal to A is equal to 1, times x minus h, which is equal to 1, squared all minus k. That's your vertex form, right? Continuing here. What should we do next? Talk to your neighbor. I know what my vertex form is. Now what should we do? Go. Okay. What should I do next, class? Put a table. Good. So we're going to create a table, XY table. What point should be in the middle of my table? 1, -1. Good. What's two smaller numbers than 1? What two numbers can I put?
2
Good. What two numbers are bigger than 1?
2 and 3.
2 and 3. Good. Okay, let's put -1 into my Should I put it into my original equation or into my vertex form? Or it doesn't matter?
It doesn't.
It doesn't matter. Which one do you think feels easier so far to do? The original or the vertex form?
The original.
I think vertex is easier, but whatever is easier for you, okay? Does it matter? No. Just get the right answer. Just still get the same answer if you do it correctly. I think vertex is easier, so let's put -1 in. -1 minus 1 is? -2. -2 squared is? 4 minus 1 is? 3. Good. 0. 0 minus 1 is? -1 squared is? 1 minus 1 is? Oh, 0. Ooh, 0. What happens when y is equal to 0? That might be a what? A solution. Good, because solutions are also called zeros, right? Or they're called, what's the third way we call them? Roots. Okay, good. What do you think the answer for 2 will be if I put in 2? Let's predict that. 0. Good. We're going to just assume that because it's symmetrical. What about 3? What's my answer for 3 going to be? 3. Good. Okay, so now we're graphing this. Okay. So -1. Well, let's start with the vertex always. So 1, -1. I once observed a math teacher. They made the vertex. They always had their students draw a heart because they knew where the center, the heart of the quadratic was. So you could do that. Okay, 0, 0. Sure, that's not very good. Next one is -1, 3. 2, 0. And 3, 3. Okay, now we're going to graph this line. All right, so we graphed it. We already know how to graph it though, right? What are we now looking for? The solutions, or what else are they called? Zeros and roots. Okay, so by looking at the graph, when is it a root? When is it crossing underneath the x-axis? At what 2 points? 0 and 2, right? So x is equal to 0 and 2. These are your 2 answers. This is a different way you could do that. Predict. What should our discriminant be? Positive, negative, or 0? What's our discriminant? Positive, right? Because there's 2 of them, right? Let me prove it to you. Discriminant is b squared minus 4ac. Okay, b squared is -2 squared minus 4 times a, which is 1, times c, which is 0. Okay, so we got -2 squared is 4. -4 times 1 is -4 times 0 is 0. So it's 4. That's our discriminant, right? You're right. It's positive. Do you see that? Okay. Looking here, when is y equal to 0? When x is 2 and 0. You all see that? Same answers. Can you guys all sing the quadratic formula one last time? Ready? And begin. That was really good. You guys are getting good at singing. You should try out for choir. Beginning choir, though. I need a little more passion. Let's try that one more time, okay? Ready? And begin. X is equal to... Smile. Okay, good. That's better. Okay, now, we know this, right? Remember the discriminant? Where's our discriminant in the square root? Do you see this discriminant? Now look at this other thing. Have you ever noticed this part? Have you ever noticed this? Negative b over... When do we use negative b over 2a? Do you all see that? Are you blown away? Wow! Easter egg, that's right. It is an Easter egg, a math Easter egg. Right? So,
That's so funny.
that is funny. Well done. I'm going to draw an Easter egg. So that's our Easter egg, okay? So, let me use some.
Not very eggy.
I'm going to use pink. All right, so everything is all connected. This whole thing with quadratics. You know, we talked at the beginning of the year. Show me with your arms what a linear graph looks like. Linear is what? Linear. Linear, right? Straight. Positive linear. Quadratic. Show me positive quadratic.
Oh, shoot.
Negative quadratic. Positive exponential. Negative exponential. Right? Remember? Oh no, that's not exponential. That's cubic, sorry. Exponential, right? It's just like that, right? Negative exponential. Just one side, right? Y'all got that? Okay, so we're doing three things. We already did linear. This is all quadratic, so now this is all coming together. So we learned how to factor them. We learned how to solve them. We learned complete the square, quadratic formula. We learned to discriminate. Now we learned to graph, and now we know how to find the solutions to the answer. Did you all get that? Okay, so this is really important. And, you know, when we talk about, like throwing a football, when someone throws a football from one end to the other, like he's black again, right? If this is the ground, or if this is the ground here, and someone is throwing the football from one end to the other, right? Doesn't it look like a quadratic graph? Wouldn't you agree? Does that make sense? So we could predict in science how high the football goes, how far it goes, what the positioning is, right? What are some other ways we could apply this concept of throwing something or launching something? What other sports can you apply this to?
Golf.
Golf, right? Don't you need to know how far to hit the ball to get it, right? Are you going to throw it as far and as hard as possible? Is there more than one way to get the ball there? Yeah, you could use a pitching wedge and just hit it as high as you can and then let it come down, right? Or you could use a driver and just go like that. But the driver will probably let the ball bounce for a while. Does that make sense? What other applications are there? Soccer, right? What about outside of sports?
Frisbee. No. Military.
Frisbee doesn't do that.
Yeah, it goes straight.
Yeah.
Throwing something at your siblings.
Okay, throwing something like kindly to your siblings, right?
Maybe.
Okay, if you want to be all aggressive, right? What if you were, let's say that, you know, there are people that are in the defense industry, and we do have the military. What happens if they need to, well, throw a grenade or like launch artillery, right? Everyone know what artillery is?
Yes.
It's like it's like a mortar, but they shoot it out of a cannon that looks like that from one end. And let's say their enemy is like 5 miles away. Let's say from here to here is 5 miles. Right? They shoot the artillery very precisely. Did you know that? They shoot it super precisely. And that isn't like new technology. That's from like almost 100 years ago. And so we use these examples in real life all the time. I mean, I know you're not going to go home and play with your artillery, but do you guys get the point? Or now here's another idea. You know, summertime. Anyone ever played with a water balloon launcher? Okay. Yes. Okay. So water balloon launcher is kind of fun. What if you want to hit your friend across the field? Right. You have to know how high and how far to hit it, right, or to hit them. So all of these applications. So what are the solutions? The solution is where you start and when you end. So let's say this is you and this is your friend over here, and you're throwing a water balloon 5 miles away. Well, might be where you are, and the solution, your other solution, is at the end. Okay? Anyways, are you all seeing the connections here? Okay, we're going to be visiting that more. Now we're going to start applying it. You've learned a lot of stuff. We're connecting stuff. And you need to know all these things. Okay, that concludes the lesson. That was a long one.